Okay, great. Thanks, Renato. So it was fascinating this morning. I mean, it gives me a great picture of some of the energy challenges in Malaysia and in the various parts of Malaysia, which was a lot of fun. And I noticed the organization of the book and the organization of the day, the three themes, technology and policy and community. And I say, wait a minute, it's missing a theme. So it's technology and it's policy and community, and it's technology and business models. You cannot talk about the energy transition without talking about business models. Leaving it out is like leaving out any one of the other corners. So part of my purpose is to put that squarely in the middle of the discussion. I'm going to talk about decarbonization of industry, not of the grid. Although I do a fair amount of work in the electrical system also. I was one of the co-founders of the energy minor at MIT, and I work on distributed coordinated electrical systems and a bunch of other things. But this is an example that I think will make the notion of business models very clear. But first, motivation. There we go. Okay. Whoops. One ahead. How do I go back? This is the control panel to the MIT climate simulator, to John Sturman's climate simulator. I don't know if you've seen it. It's a fantastic way to look at overall climate effects. And you basically have controls on energy supply and controls on the transport sector, controls on building and industry, controls on land, food, and land use, controls on carbon removal. And the whole objective is you move the sliders to different combinations and you see how you can drive the system. And we do it with groups of students. We do a group with the policymakers. They've done it with at the UN level, with heads of state, in all kinds of places. And you can, right now it looks like we're going to do about 3.3 degrees C in the model. You can find ways to get to 2 degrees C. There are lots of different ways. It's quite interesting because there's some very regulatory ways of getting there and there's some very market ways of getting there. But it's not easy, right? It's really hard. Number 1 point. Number 2 point is it's going to require changes in many systems. So here you're focused on the power system. Worldwide and in the US, the energy supply system is only about 1/3 of the problem. So if you make the grid in the United States completely green, you've solved 1/3 of the emissions problem. The public thinks that all we need is renewable energy. Everything else will take care of itself, right? And the point is, it's necessary but not sufficient. We must green the grid, but we also have to green industry and housing and transportation. And we say, oh, we can just have electrical vehicles. Well, what are the cars made out of? Metal. What do they drive on? Concrete. What does the concrete displace? Forests. If you go from electric vehicle or from gas vehicles to electric vehicles, what percentage of the total emissions have you removed of the motor vehicle transport system? About 20%. The public thinks you removed it all because there's no tailpipe emission. But as cars, roads, tires, friction, you still have to move the friction. And one of the problems is now you're moving 2 tons of friction because you got a 2-ton battery instead of 1.5 tons of friction, right? So we obviously have to change the food and land use system. We clearly have to change consumer behavior. I very consciously said there are 4/3 because in fact they're kind of interacting effects. But solving the problem is solving the 4/3. Industry. So I'm going to focus on industry. And I'm going to focus on cement as an example. It's a very boring example, but cement and concrete generate 7% of global emissions. 7%. Steel generates what, 4 or 5%? Aluminum about 4%. So if you take the materials we use, you add them all up, you get to about 1/3. Just the stuff, right? And you look at people do studies on energy efficient buildings. and they talk about savings in HVAC. They don't talk about savings in concrete and steel and aluminum. And yet, over the life cycle of the building, about half of the life cycle emissions are in the materials as opposed to the use of the materials. So I'm kind of saying hardware matters. Hardware matters, and we've got to decarbonize industry. We've got to change where we live. We've got to build cities so not everybody has to sit 2 hours a day in cars. I mean, I thought the US was bad in that respect. KL is worse. I can't walk anywhere in this city. I can't walk anywhere. I have to go across an 8-lane highway to get any place, right? And everybody just sitting there in their car. What kind of urban design is this? It's, right? In a beautiful green place. So reimagine that city where it's a 15-minute city where everybody can do their daily life within 15 minutes and they can commute to work within a half an hour on public transportation, right? That's what you have to do over in the transport system. So there's work for everybody to make this transition. Okay, let's dig into industry. So I'm an action guy. I'm a management prof, and I'm cheating on this slide. Actually, this presentation I'm cheating because we did a 6-module program for Bain, the consultants. It was virtual, and 1,500 students, and now 15,000 of them are seeing it. And we had people, it was really fun because it was all of MIT. So we had climate scientists, and we had engineers, and we had economists, and we had agronomists, as well as management folk. But part of my part was, you know, how do we go from, oh, I guess I still even left the trademark of the course up there, sustainability in action. But how do we go from talking about programs and plans and things that need to be done to getting action? And now I'm talking about action at the level of a company. You also need action at the level of a community. You also need action at the level of a government, right? You need action at you need action at the level of inventors and technologists. How do you go to action? Well, the natural point to start is the material point. What's the impact? So whatever activity you're involved in, what is your impact on the environment? And then what influence might you have over that if you paid attention to it? And we generally say that companies are polluting because they're evil. That's probably true, but I tend to think that companies are polluting primarily because they've never thought about it. A lot of unsustainability is unconscious. If it becomes conscious, then I think there's more attention. But strategic focus and targets, and then strategies, which are both technology roadmaps and decarbonization roadmaps, and then making it happen. So that's more or less my outline for the day. Now let's jump into the wonderful, exciting, sexy world of cement. This is an industry curve. This is the Global Cement Producers Association. And if we're going to get to net zero by 2050 in the cement sector, how's it going to happen? Well, a big piece of it is going to happen by carbon capture. Because those of you who know anything about the production of cement, you take limestone and you cook it at very high heat to release CO2. So it's double CO2, CO2 to heat, and the heat to release CO2, right? So the core process itself is emittive. Well, this is probably wishful thinking, right? This says we're going to be able to, although this is a fairly efficient place to capture carbon because the flue of a cement kiln is a very concentrated flow of CO2. So it's probably a pretty good place to get it, but you still need a carbon tax that's $100 per ton or more to make it work. Some of it, notice, if we decarbonize the grid, what we're focused on here, you get rid of about 6% of the emissions of cement. Not much. Why? You can't make cement with grid electricity. It takes 1500 C. It requires huge heat. You've got to get it some other way. You can do it with nukes, right? You can do it with coal. You can do it with oil. Although I have a colleague at MIT who actually now has a commercial scale pilot going that is fully electrical, no CO2 release. So there are new technologies, but the big one, well, recarbonization, yeah, carbon capture and storage, savings in clinker production. Clinker is, I'm not an engineer, I'm not a technologist, but it's the sticky, it's what makes it work. And traditionally, how do you make good cement? You make good cement by having excess clinker. So most of the cement in the world is stickier than it needs to be. And in the US, it's like twice as sticky as it needs to be, partly by regulation. So we have foolish regulations that lead us to have material that is stronger than it needs to be, and therefore it is more polluting. And all you have to do is use less of that stuff. You just have to pay attention. But paying attention means changing regulation. It means changing the mindset of the buyers and users. It means much more technical quality control, because if I have excess clinker, my quality control is done by having excess. If I pull it down to just the right amount, then I really care whether the batch is well made or not, right? And the manufacturer is going to have to be able to certify to the buyer that they have really, really good control. So notice I'm starting to say the business model starts changing. I have to be able to actually show you and prove to you that the cement you're buying is of good quality. I can't assure you that I just have extra stuff in it. This extra stuff is bad for the world, right? If you use any material that is more than necessary, you're doing a bad thing in terms of emission. How many of you were trained as engineers? How many of you build a safety factor into your structural engineering? All of you created excess emissions. If you'd been more careful in your calculations, you could have cut it closer and got away with less material, right? Okay, but anyway, I'm just trying to make this real. I'm just trying to make this real. Savings in cement and binders. This is basically go to non-petroleum binders. Efficiency in concrete production. And then very interesting, the big one, efficiency in design and construction, where you actually use cement better. This is important because most of the way we measure efficiency in the industry is emissions per unit of production. That would totally miss that piece, because that's efficiency per unit of service. Per 1,000 kilometers driven, per 1,000 square feet of building, right? Not per ton of concrete. So we increase the efficiency by using less of it, or by making it less emission intensive. Okay, you got the picture. Lots and lots and lots of technical possibilities. And the engineers can have great fun, and the chemists, I guess the chemists play in this game, can have great fun with all these things. But let's think a little bit about how to judge the options. Are they profitable enough? And if you business school speak, what do they cost to produce? How much would a customer be willing to pay for them? But how much does the customer actually have to pay for them, which is what you could get them for from the competition, right? You don't sell for willingness to pay, you sell for price. You sell for competitive price. So you're trying to create economic value by a difference between price and cost. Do they provide a good sustainability ROI? Are we actually getting a decent reduction in emissions, let's say, for the cost? But then what we don't usually think about is, do they require a different business model? Do they require the firm change what it does in order to do this? Different product, different process, different assets, different capabilities, which I tend to focus, different ecosystem or complementers, different relationships. And then, are they backed by current public policy, or what policies would best support them? So walk up to any industry, and you can draw a curve like I just drew of different technologies that could abate emissions in this industry. Then you start asking these questions about policy and business models, right? And then you start putting the structure together. This is the way I like to look at business models. This is David Teese's work, but modified by my friend Hiram Samuel, who's a political economist like Renato here. I have the value proposition, which is I sell the product to you. What does it do for you? How much would you be willing to pay for that? How much benefit does it give you? Right. I have the delivery side, the value chain. How do I make it? How do I deliver it to you? And then finally, the important part, how do I make sure that I hang on to some of the margins, some of the difference between price and cost? How do I keep the competitors away? Because otherwise, price is going to be equal to cost. It's going to be a pure commodity, right? So what are my isolating mechanisms? So first step, clinker. We're going to cut back on the amount of clinker. Where's the action? Well, it mainly changes the value chain. It reduces cost. Does it make me any more profitable? Not clear, because if everybody does it, the price is going to fall. The environment's better off. The price is going to fall. I'm no better off. Now, maybe if the engineer or the constructor is now nervous about quality, I will get an advantage if I'm viewed as a technically sophisticated company because I can do better quality assurance. I built this all on the series of cases I wrote on Cemex, which is the Mexican cement company. And they were leaders in selling cement by bags as opposed to selling cement in trucks. Who do you sell cement in bags to? People that build their own houses. Most of the world buys bags, right? And it turns out people who buy cement in bags are really concerned about quality because it's their savings that they're using to buy the cement to build their own house. And they can't test the quality. So they pay a premium for a brand. People who are building superhighways don't pay a premium for a brand because they can test the quality of what's coming in every day, right? But so it has a business, possibly a business model implication. It reduces cost. It may not make you more money. In fact, there's probably a limited incentive for any one firm to do it, because once you do it, everybody does it. You got to move the whole industry. You need regulatory change. You need the regulation to say, oh, the minimum amount of clinker is now X, and the maximum amount is Y. And we're just going to reduce the emissions of this sector. Second, so Cemex is very big in North America. It's very big in Europe. It's huge in Latin America. It's basically a monopolist in Mexico. But 70% of the urban waste in Mexico City is burned in a single cement kiln by Cemex. Mexico City is 12 million people. Gives you some sense of how much heat is used in a big cement kiln. And in a sense, the comparative advantage of the cement company is it's unique in having this huge need for heat in a single location. So they expanded their business model to become the waste collectors. They're now running fleets of trucks. They're dealing with all kinds of industrial unions. It's a totally different business. They've reduced the carbon footprint of cement quite a bit. And frankly, they're making money. They've now spun off the division. So they're now expanding internationally as waste collectors. Why? Because they need a lot of heat and they know a lot about combustion. Why did they know a lot about combustion? Because 30 years ago, they started looking for cheap energy, and they found that if they burned tires instead of petroleum, it was cheaper. And if they burned corn husks instead of petroleum, it was cheaper. And then they bought a company in Spain, and they discovered that the Spaniards were burning petroleum coke, the leftover of making petroleum. And then they looked around at home, and they realized there was a lot of pet coke, because pet coke is a result of heavy oil and poor refining, which I've just defined Mexico. But so they were very good at cheapening their production by looking for alternative fuels, but they turned that into a capability, and actually a scientific capability, so they're the best on combustion in the industry. So they know how to get competitive advantage of that. So where's the action? It's largely there. But it's also a fair amount in the value system because you've got to be large scale and you've got to have capabilities to do it. So maybe I can make money and others may not enter so easily. So now I'm starting to bring you into an MBA class, right? I'm saying, let's think about decarbonizing, not only doing good, but let's have a hard-nosed calculation of whether it makes money for us or not. There's no necessary conflict between the two. Third, green concrete. Green concrete, where's the action? There, probably over there, right? What's green concrete? We probably make it efficiently with a little less energy. We combine it with better aggregates. Actually, we can reduce the carbon footprint of concrete by about 60% with no change in technology. Now, does the United States have a carbon policy or not? Not really, except if you look carefully at the IRA, the Industrial Recovery Act, which is actually the Climate Act, the Infrastructure Act, you'll see that it mandates any highway paid for partly with federal dollars must be made with green concrete. That's huge. That happened 2 years ago. It's huge. So we do have climate policy. It's not what economists would like. It's not a carbon price. It's not uniform across all levels. But hey, if it does cement and steel and aluminum, and oh, by the way, the defense industry has to take it into account in buying aluminum too, it covers a lot of the sectors. So green concrete may be more expensive to deliver. It's going to be different for the customer. They may be willing to pay more for it. They may, in fact, have to use it. Is it going to give you an isolating mechanism? Well, if only some companies can make that conversion, and if the supply of green concrete is now scarcer than the demand for green concrete, I can get a premium price. And I started off in a commodity business, and suddenly I have a differentiated product. And surprise, surprise, Cemex owned a lot of the aggregates. So they owned the complementary assets that are required for green concrete. So they can beat the other ones, right? No? So we're reducing emissions, we're reducing emissions, we're reducing emissions, we're doing good things for the environment, but there's some cold-hearted business calculations in this too. And the business calculation will differ depending upon the size and technological capacity and capabilities of the company. Different business models. There are many more degrees of freedom on business models than there are in technology or on policy. I think I have one more. Yeah, urban solutions. So Cemex is going urban solutions, recycling. What proportion of the materials out of recycled buildings are recycled? Right now, it's probably 3%. And all of those materials are very emissions intensive. If we could recycle 30 or 40% of those materials, we'd make a huge difference. Who's going to do this? The constructors, but it's got to have someone with a large intake of those materials that can recycle them, right? So it's a new business. But then you think forward into new designs or so concrete is now 3D printed. Not poured anymore, it's 3D printed in the building, and then you have new designs of the building. If you make the concrete pieces of the building in an enclosed space, you can actually fill that enclosed space with CO2, and the concrete will absorb the CO2, and actually will become negative CO2 as opposed to positive CO2. All kinds of things you could do. Okay, so enough. And you don't want any more of cement, but you could repeat this on any other business. So walk up to any industrial sector, what's possible from a technological viewpoint, what kind of business model does it entail, what kind of policy context does it require? That's the question you would ask. Okay, enough of that. Tech and policy scenarios, 1.0, 2.0, 3.0. I like to talk about sustainability 1.0, sustainability 2.0, sustainability 3.0. Sustainability 1.0 is everything you can do with today's technology and today's policy, if you just pay attention. So maybe the first thing you do is you green up your existing process. You look around and you say, hey, we're being wasteful. We're just not paying enough attention. Let's just be better. That's the first step. But let's improve our process. Let's improve our product. Let's improve the overall business model. That's kind of 1.0. Green up current business model, raw material extraction, clinker, green concrete. Second stage, what could we do with current technology and policy context if we adopted a radically different business model? If we extend our business model from making concrete into also sourcing our own heat with waste, that's a new business model. Or if we extend our business model to designing and constructing the components of the buildings or the highways that are built with our concrete, we could decrease emissions, still within the same technology and policy envelope. 3.0, new technology and or policy. Let me tell you that there's going to be a $200 per ton carbon price, and there's going to be a fully electrical way to make cement. Okay, I'm going to do something radically different. And if you start thinking about these things in temporal terms, right? In the short run, it's 1.0. Medium run, it's 2.0. Long run, it's 3.0. Every sector, this is, we talked a lot about transparency and measurement. There's some pretty good stuff out there. This is the Transparency or Transition, TPI, Transition Pathways Initiative. And they publish scenarios on many, many different industries. You can go and look at them online, and they have detailed stuff on the firm. It's a great teaching tool. So here you can look at Cemex, which is the firm I was focusing on, Holcim, which is the Swiss-French firm that leads in the Western world. The Chinese firms are bigger these days. Heidelberg. And you can look at what's their carbon intensity per ton of CO2 per ton of cementitious product. How are those changing? And over here they have a net zero target. And do they have a target? Are they on track? It's nice to know. To me, that's not sufficient. That's necessary, but not sufficient. I don't believe anybody's target unless they tell me what are they doing. The target is generated by the PR office or by the ministry or by the consulting firm. Show me what you're going to do, and then tell me what I'm going to go actually look at and see whether you've done it. And emissions relative to current level, let's say I'm going to bring them down to some minimum. What am I doing in the short run, medium run, long run? Long run's going to be about 20. It's got to be 2040 if we're going to survive 2050, right? And I really do believe 2050 is a good horizon. If we don't turn parts per million in the atmosphere around by 2050, forget it. It's your problem, not mine. But I mean, it's really serious. It has all kinds of implications. Because if you take a 2050 target, then the weighting of methane in greenhouse gases goes way up. If you take an infinite target, methane doesn't matter very much. If you take a 2050 target, methane really matters because it has a shorter half-life than CO, right? So these things matter. Where's your target? How are you managing the overall situation? But I want every firm to show me this, and I want this to be baked in inside the firm. I start with continuous improvement. I start with operations. Digitized efficiency, renewable energy, attention to detail in every activity. Who owns this? Not the chief sustainability officer. This is owned by the head of operations. Chief sustainability officer can talk about it, but it's embedded in the continuous improvement of operations. But at the same time, I've got to be doing pilots for the medium run, and I've got to be doing ventures for the long run, right? So right now, I'm cutting my emissions, but I'm already trying some things that are the next step. And I'm investing in companies that have got the new technology so I can bring them in. So I'm working three different time horizons at once. Medium run, step up, new products, asset upgrading, much greater circularity, right? I'm stepping the firm up quite a bit. Long run, transformation, fundamental change in my processes. We've been doing it in the same way for 2,000 years. We never worried about the emission. In a period of 10 years, we're going to fundamentally change the process, period. And we're probably going to get around to carbon capture because people say, oh, we're going to all be all renewable. We don't have to worry. And that would be nice if the world was not material. But the world is material, and materials involve emissions. And therefore, you're going to have to find negative emissions somewhere to offset material use, unless we all join Elon Musk out there somewhere in an immaterial world. All right. Let's see. How am I doing? Poorly. This is my last slide. I'm almost on time. So we can spend a lot of time. Do you have the stuff in place to make it happen? And this is the conversation that the regulator should be happening with the company. This is a conversation that the investor should be having with the company. And this is a conversation the community should be having with the company. They say, you guys tell us that you have a target. You guys tell us that you have a program. Show us that you actually have the management mechanisms in place that could cause us to believe that. If you can't show that, why the hell should we believe you? Do you have a focus and target? And if your focus says we follow the 17 SDGs, forget it. Tear up the piece of paper. No firm can follow 17 goals. They better pick the 1 or 2 or 3 SDGs where they have the biggest impact and the biggest possible influence. And then they'll say, and we're going to meet the community standard on the others. We're going to pioneer on these, right? We're going to focus on these because we know something about it. Our technology, the way we do things, will allow us to have a special impact on these 3 SDGs. And very, very explicit, not just target, not that we want to be net zero in 2050, but there's a pathway. And behind that pathway, there are actions, and they're traceable actions. And it's managed, and we're having fun with the students on this. I better have a very good chief sustainability officer, but she better recognize that she has no direct power, and she has to work through marketing and operations and engineering, and it has to be a distributed activity throughout the firm. And it has to be built into people's incentives. And they also have to believe it. And if they're going to believe it, they have to be engaged in it themselves, right? All of that. So that's my half hour of decarbonizing industry. But my key point was to say, it's easy to talk about the fact that business is evil, but business is your partner. And you're not going to decarbonize anything without business making the changes. It's easy to look at business and say, all they care about profit, and at customers, all they care about cost. Then it's all regulation. Renato has a wonderful action learning team here that's looking at GT Tire Company. And how do you decarbonize tires? Well, you can decarbonize tires by coming up with cleaner materials. The biggest way you decarbonize tires is reducing the rolling resistance, because it uses less fuel, right? It's not in the company. It's scope 3. It's not scope 2. But that's the biggest impact you could have. You start thinking about where's the impact of your product and how your product is used. And what do you have to do? You're going to have to get out to the distributors. You're going to have to work with trucking companies. You're going to have to make calculations. You're going to have to show them that, in fact, the lower rolling resistance tire is actually higher economic performance, and it's also higher environmental performance. And, oh, by the way, if you buy it from us as opposed to buying a commodity Chinese tire, you're going to be better for the environment, and we'll make more money. End story. Okay, any questions? Yeah.
I've interviewed people about this kind of topics, and they're saying the transformation for sustainability carbon reduction is similar to the safety drive that you had here about 20 years ago in industries like oil and gas. Do you agree with that, or you say, no, it's really different?
I think it's bigger. So I know a lot about the safety drive in oil and gas. I did Projects Academy with BP for many years, but that's largely focused on my internal operations. So, but let's imagine that I'm, GD, your Indonesian friend tire maker, and they really care about emissions, and they do, and they'd like to make money too. So they're going to have to source their materials differently. There's natural rubber, there's carbon black, there's a whole host of things. And that's going to be beyond the boundary of the firm. So that's going to get in all kinds of the community stuff in Malaysia, right? It's kind of the upstream sourcing from smallholders and the whole chain. They're going to have to change the way they engineer their products to have environmental performance as a criterion as well as economic performance. They're going to have to change the way they produce things to make sure that they actually produce truly, right? But then they're going to have to communicate to customers differently, and they're probably going to have to work with customers. And who's going to convince a trucker to put a quote better tire on? It's probably the tire distributor, and he's probably going to have an app where you can say, let's look at how heavy your loads are and how many kilometers you drive every day, and let's see what the economic advantage is to you, right? And everything in that firm has to be touched. In the oil and gas company, it's kind of the way we do our stuff. So I think it's bigger. And that won't be true. There's some wonderful, think about Walmart or Amazon or Shopee. Their direct emissions are their logistics, moving the stuff around. A little tiny bit, the electricity required for their digital platforms. The emissions they influence are the emissions in the lifetime use of the products they sell. Now, you go on Amazon's website or Shopee's website and try to figure out which air conditioner is most environmentally efficient. It doesn't tell you. They're doing a lousy job in managing their environmental footprint. Their potential is in influence on the downstream use. I don't care. I do care, but I don't really care very much whether they reduce the footprint of manufacturing the thing. I care whether or not they manufacture a thing that uses less electricity. On and on and on. Yeah.
Hi, Professor. I'm Raymond, second year MBA at ASB.
Great.
I did a project last year in Singapore regarding new ways of recycling EV batteries.
Yes.
With Prof. Renato as our advisor.
Great projects with Prof. Renato.
Yeah. My question is, with the current situation of deglobalization,
right,
in terms of electric vehicles and all these. What do you think about countries trying to build their capacity in terms of manufacturing with their own standards, and of course the circularity of it, being recycling it so that they don't rely on mining resources like China or South America?
Well, I answer you the same way as you answered about the policies. Is it A or is it B? You're saying should all be national, or it should be totally global? No, it's going to be somewhere in between.
Yeah.
I hope we have a common set of standards. I hope we have some interchangeability. There are very significant efficiencies to international trade and connection. We're past deglobalization. We're into a new multipolar world. You're in one of the most interesting parts of the world because you and Indonesia are suspended in a lake of India and China and everybody else. I guess Tesla's coming here, right? Why is Tesla already here? Why are they coming here? Because you're not China. So actually you're using the quote deglobalization in your advantage in your globalization. Now, where should the battery be made? Should it be made here? Should it be made in where the raw materials are extracted, which may be Indonesia? Should it be made in the US? And you will try to convince the US that you're friendly enough that it should be made here. I guess I'd probably start off with a physical calculation. I say words that make sense. But then I'd say, now it's a behavioral conversation. Where will people be most engaged in the process? And if it doesn't have some national stickiness, there'll be no engagement. If it's totally globalized, it's out there. Somewhere in the middle probably matters. I taught a course like this in Chile last year, and they have a national recycling law. Malaysia could have a national recycling law. So it says the manufacturer is responsible for the recycling of the product they sell. Because physically the product gets used in a country. It may get produced through a global supply chain, but physically, so it's a fantastic question. Now, how do you go into it? You say, there are some sweet spots in it where profitability and environment. And the sweet spot will differ depending on who you're talking about. The sweet spot for BYD is going to be different than the sweet spot for Tesla. And Malaysia's got to think about what sweet spot does it want to craft with its policies. You're going to have a great career.
Thank you, thank you.
Yes.
Question,
Good.
but it's kind of like using Malaysia's example in terms of policy implementation from high level all the way down. Because from what I noticed is that the way policy has been crafted around here is very much focused on the realities in, how do I say that? Capital cities in Malaysia,
Yeah.
right? So whether it's about recycling or whether it's about energy distribution, all that, I feel like, for instance, even in smaller urban areas, they tend to get left out. So in terms of infrastructures that are built to support, first is recycling, right?
Right.
So much of the recycling that's done is very focused on cities like,
Right.
the Klang Valley. But
Right.
once you go, let's say 2 hours out to Perak, right? The recycling chain breaks down.
And
It doesn't really.
And maybe it should, because maybe if the population is not that concentrated, recycling is not economic.
Yeah.
Pardon me, but recycling has its definite limits. We think that recycling is going to solve the problem. I have colleagues at MIT who look deeply at it, and the proportion of the stuff that can be economically recycled is limited. So you're going to have to reduce the amount of stuff you use in the first place. Then you have to reduce the emissions of the stuff in the first place. And you shouldn't be drinking out of a plastic bottle, because the recycling will never undo the damage of that plastic bottle, because about 7% of the plastic bottles maximum will get recycled.
Yeah. But the problem is a lot of our roadmaps is still very much premised on this idea of centrality. Like everyone should just copy what happens, let's say, in Klang Valley, as opposed to hyper-locality, each location with their own specific economics and population.
Well, that's why it was fun for
demographics.
me, hear the difference between Sarawak and Peninsular, and then the urban versus the rural. Malaysia ought to be a place that tailors very specific policies to cover the variety. Because it's quite a sophisticated place, and the variety is quite visible. I take your point, but there are goods and bads of a city. So you're going to do things differently in the city and elsewhere.
I just have one comment and one question.
Okay.
Okay.
That's a good ratio.
Yeah. Comment on recycling is that it's very difficult until we can actually segregate at source. So a lot of times, what is being done with the waste is actually incinerated and turned into energy and energy recovery. So there's again a structural change and also a behavior change that needs to happen in terms of segregating at source in order to optimize the recycling amount. And that's just a comment. Number two is more of a process question rather than a policy question. You talk about CEMEX, that they actually use a lot of heat.
Yeah.
Right.
Any cement company uses it.
Of course. And do they actually recover the heat to actually create or produce electricity from that heat?
They recover their heat and largely use it industrially, although around their kiln, they actually have an industrial park, and they have a lot of heat using processes of other people. So they have a heat market.
Right. So they also use that to.
Right. Remember, Electricity travels, it doesn't store. Heat doesn't travel, it stores. I mean, I'm overstating the case because Darlene was trying to break that, but yeah. I mean, an effective system is going to co-locate the heat sink with the heat source. And it's gonna make sure that and look here or in US or New York, where do we put our big power plants? We put them out someplace.
Yeah.
So what happens in the heat?
It goes out,
Totally wasted.
definitely.
We're very proud that we have a cogeneration plant at MIT. It's a big power plant. All of the heat heats the buildings at MIT. Now, you don't need, well, you have air conditioning, so you can use it too. So the engineering of heat use. So it'd be nice if we could find materials that don't need the heat.
Mhm.
But if I do need the heat, then I better have a good heat recovery. And there's typically a, I don't know, 10, 15, 20% factor of emissions by being very clever about heat management.
Right.
And so now I want to be thinking jointly about managing heat and electricity. And I want to be thinking about, is it better environmentally to throw all of my trash into an incinerator
Mhm.
and capture the heat, or segregate it and recycle it? People think it must be much more environmentally sound to recycle by piece. It may not be. It may not be worth it. We always have to make an economic calculation as well as the environmental calculation. I was trained as a finance guy, so I know what a net present value is, but I can do a net present environmental value also. I'm trying to create values, right? And when I talk about a sweet spot, I'm talking about a frontier. I want a place that is profitable and environmentally sound. I know there are places that are profitable and that suck from an environmental perspective. I know there are places that are environmentally sound that are not profitable. I hope there's something in the middle. Otherwise, we're not going to make the transition unless we mandate it or pay for it by taxes. All right, back to you.
Thank you so much.